8-1. We're going to start with number 1. We have a sequence defined by this rule, an equal a to the third minus 1. We're asked to find 6 terms in that sequence. We're going to start by n equal to 1. To get to the first term in this sequence, it will be 1 to the third minus 1, which is 0. We're going to say n equal to 2 to find the second term, and that will give us 2 to the third minus 1. 8 minus 1 is 7. Then we're going to let n equal to 3, and so gives us the third term, which will be giving us 3 to the third minus 1. 27 minus 1, 26. You're going to continue this pattern to get 7 of them. Number 2. You're given a rule, we're calling it f of n this time. It is negative 2 to the n minus 1. We're asked to find the sixth term, the first sixth term. So we're going to let n equal to 1, which means the first term will be at negative 2 to the 1 minus 1. It will be negative 2 to the 0. Anything to the 0 power will be 1. Then we're going to let n equal to 2 to get to the second term. And so that will give us negative 2 to the 2 minus 1, which gives us negative 2 to the first. N equal to 3 gives us the third term. It will be negative 2 to the 3 minus 1, which gives us negative 2 squared, which is positive 4. You're going to continue this pattern until you get 7 of them. I'm going to do one more for you, and you do the rest. A4 will be negative 2 to the 4 minus 1, which gives us negative 2 to the third, which gives us negative 8. Please continue till you get 7 of those. Number 3, we have a new rule. An is equal to raised to the 2n. We need 6 terms, so we're going to start with n equal to 1 to get to the first term. And so that'll give us 2 to the 2 times 1, which gives us 4. Then to get to the second term, I'm going to let n equal to 2 and substitute 2 for n will be 2 to the time 2, which gives us 2 to the fourth. 2 to the fourth is 16. Continue with this pattern, n equal to 3, n equal to 4, n equal to 6. I need you to continue, and then you get the answers. 2 times 3 is 6. 2 to the 6 is 32. Please continue that pattern to get to the next one, A4, which is 256. You get A5 to be 1024, and to get to A6, which will be 4096. Number 4, 5, and 6, we need to describe the pattern. So we have the pattern that's listed in that particular sequence. Our job is to find the rule. I did find the rule, but I want you to ponder on this a little bit and figure out a way to get to that rule. And so I came up with 2n minus 5. I want to test it though. If I let n equal to 1, would I get the first term? A1 equal 2 times 1 minus 5, which is negative 3. Yes. I'm going to test the next one. Maybe I will test the third one. What if n equal to 3? Would I get A3, the third term, to be 2 times 3 minus 5? 6 minus 5 is 1. And A3, which is this term, it is equal to 1. Continuing with number 5, you have this particular sequence: 2 over 5, 4 over 5, 6 over 5, 8 over 5. I'm going to look at this particular sequence and I find all the denominator is 5. So my rule, maybe it should be something divided by 5. If you look at the numerator, and here is the numerator: 2, 4, 6, 8. It seems to me they're all multiple of 2. Could it be 2n? Test it. Let n equal to 1. See if you get the first term. It will be 2 times 1 over 5, which is 2/5. Test the fifth one. The 1, 2, 3, 4, 4 one. N equal to 4. Would that give you 2 times 4 over 5, which is give you 8 over 5? And that would be checked. Continuing with number 6. Number 6, we did it in class. I want you to list it in a sequence: 3, 9, 15, 21, 27. As you can see from this sequence, you're always adding 3. And so because you're always adding 3, I'm thinking to come up with a rule, I need to start somewhere and then subtract or add something to get to 3 for the first term. I came up with this rule, and if you remember, we did it in class. Let n equal to 1 and test it. See if you get the first term. Would the first term give you 6 times 1 minus 3? That's good. Test it with another number. Continuing with number 9, I will come back to 7 and 8 in a minute. Number 9, you're given the sigma notation. Sigma notation, that means we have to add a sequence of number. They're put for you in this particular formula. So what I want you to do first, generate this sequence and then we'll add them up. So if n equal to 1, we're going to start at 2 and then we're going to end up at 5. So we cannot start at 1, we have to start at 2. The first term in this sequence will be 2 over 2 minus 1, or simply 2. If I want to get to the second term, will be a3, because we're going to let n equal 2 to 5. N equal to 3 will give us the second term, which gives us 3 over 3 minus 1, which is 3 over 2. Now continue with this pattern till you get to 5. N equal to 4, which gives us the third term, which is 4/3. And then if you do the last one, n equal to 5, you get the last term, which is a4, which is equal to 5/4. Now what you need to do is add those numbers. Now to add them up, I need you to do it without the use of a calculator. We're going to do a common denominator and add them all up. The common denominator here is going to be 12. So this will be 24 over 12. This will be 18 over 12. And this will be 16 over 12. This will be 15 over 12. When we add them all up, we get 73 over 12. Ta-da! Number 10. Number 10, we have the sigma that goes k equal 1 through 6 of this rule, k squared minus 3. Now your job to generate this sequence and then we'll add them all up. Sigma means add them up, the sum. So the first term, to get to the first term, we're going to let k equal to 1 will be 1 squared minus 3. The next term will be 2 squared minus 3. The next one will be a3. That will be 3 squared minus 3. The fourth term will be 4 squared minus 3. And so on till you get to 6. That will be 5 squared minus 3. And a6 will be 6 squared minus 3. If you add them all up, and you will get this one is equal to -2, this is 1, this is 6, this is 13, this is going to be 22, this is going to be 33. Now your job is to go ahead and add them all up. If you add these terms in that sequence, you will get a grand total of 73. Okay, number 11, you have this sigma notation where I goes from 3 to 7 of this particular rule 5 over I. That means when we start the counter, we're going to start it at 3 to get to the first term, and which is going to give us 5 over 3. To get to the next term, we're going to let I equal to 4. That gives us the second term, which is 5 over 4. Then the next one will be I equal to 5. And so that will give us the third term, which is 5 over 5, which is of course 1. Then we're going to go to I equal to 6, and that will give us term number 4, 5, 6. And finally I equal to 7, because this counter is going to end at 7. And so this will give us the fifth term, which is 5 over 7. Now your job is to go ahead and add them all up. To add them all up, I need you to do common denominator. And the common denominator is going to be, we're going to add 5 over 3 plus 5 over 4 plus 1 plus 5 over 6 plus 5 over 7. Do common denominator of 84. So where do you multiply the first term to get 84? It's going to be multiplied by 28, so that's 140. Here we're going to multiply by 21, and it will be 105. Here we're going to multiply by 84. And here it's going to be multiplied by 14, so that'll give us 70. Here we're going to multiply by 12, and it's going to give us 60, for a grand total of 459 over 84. Number 7 and number 8, I really want you to spend some time on them to figure them out. But as you can see, number 7, we already wrote the rule on number 6. So you have the 3 plus the 9 plus the 15 plus 21 plus 27. To write this rule, we're only going to say, okay, since they're all added up, It's the formula that we came up with in number 6, 6n minus 3, but the counter is going to go from 1 to 5 just because you have 5 terms. If you count them, you get a total of 5. As for number 8, you're given a numbers here that are alternating. -1 plus 4 minus 9 plus 16 minus 25 plus dot dot dot. The reason they alternate, that means you're going to have to multiply by -1 to a power n. So when you let the counter equal to an odd number, the negative stay. If it's an even number, it will change. So we're going to let n equal 1 through infinity because it's dot dot dot. And this one, if you look at the numbers, 1 is 1 squared, 2 is 4 squared, 9 is 3 squared, 4 is 16 is 4 squared, 5 is 5 squared, 25. So I'm just going to multiply them by n squared. I do want you to go ahead and try it. Let n equal to 1, see if you get the first term. Let n equal to 2 and get the second term, and so on. As for number 12, I want you to think about this problem. I want you to let n be the number of tables, and I want you to let a of n to be the cost of renting these tables. So once we defined our variable, the rule should be it's going to cost us $100 plus $7 per table. So that means if we want to get 1 table, the cost is going to be 107. If I want to get 10 tables, and this will be 100 plus 7 times 10, which gives us $170. Test it. Finally, number 13. And for number 13, you're making a party favor. So after the first hour, you have 636. On the second hour, you made 2 more. And so this is after the second hour. After the third hour, you have to make 2 more, which is 40. And then every hour, you add 2 more. And so you worked for 7 hours. And your job is to count to see how many you have. This is the 4th hour, this is the 5th hour, and this is your 6th hour, and this is after the 7th hour. So how many do you have? Go ahead and add them up, and you will get 294. Now, if you want to go ahead and put these in a rule, like a sigma notation, I will put the counter to start from 1 to 7, because I'm working from hour 1 to hour 7. And if you look at the rule here, go ahead and look at that sequence. Can you generate a rule that generates those sequences? And I found it to be 34 plus 2i. It's not the only rule you can come up with. Try to come up with another one. Good luck.